our podcast on efficiently using safety and security standards. My name is Christoph Ebert. I'm the Managing Director of Vector Consulting Services, and I'm going to give you some sort of overview how you can efficiently use a variety of standards. The challenge today is that standards are evolving almost like mushrooms. The reason is obvious. Standards give us some sort of framework where we can rely. Imagine interfaces. Interfaces in IT or in communication network are defined by the OC stack. It was a very key standardization activity many years ago, which helped that we could create different communication systems like CAN, Ethernet, etc., which can communicate on the different abstraction layers. So definitely standards are relevant. Standards are also very important from a legal perspective because we have a product liability worldwide. That is, if you bring a product to the market and the product creates a hazard, has a defect or otherwise problems, you have to prove that you follow the state of the practice. And the state of the practice is the consolidated amount of standards which are released at the moment when you have developed the product. That is, it is certainly worth to look to the standards. On the other side, we have a huge quagmire, that means a real jungle of different standards which impact each other. So we will give you also a short overview into how to cope with these standards. Now, in the field of safety and cybersecurity, we can see a clear relationship, which is if we put safety security together, let me see, we have on functional safety standards like the initial IEC 61508, we have the specific functional safety standards like the 26262 or the 25119, which is in machinery or off-road vehicles. And we certainly also have a set of methods. In cybersecurity, we have also standards like the initial ISO 27 series. Then we have the standards which is specific for automotive and vehicles, which is for instance the 21434, or we have domain-specific standards, regional standards like the SAE 3061, which are specific cybersecurity standards for vehicles. The 27 series, this is security management. Now, looking to these two domains, we can already realize there must be overlaps. Sure, take a safety goal, drive a vehicle, and there are some assisted braking or ADAS functionality which could be manipulated. That means our safety goal would not anymore be achieved if the code or some calibration or configuration parameters can be changed. This being said, it's very obvious that we have to harden the safety goals and their implementation. Now, a safety standard could actually just include also a threat analysis and try to harden. But that would be a real pain because then we would have the safety standard as a book which refers to cybersecurity, but maybe also other things, requirements engineering because you have to define the requirements, testing because you have to test your safety implementation. This makes no sense. So ISO already many years ago has decided to make some sort of abstraction and architecture of their standards to ensure that the standards have the minimum overlap. They refer to so-called shared methods. An obvious shared method here would be that if we do a hazard analysis, we also have to make a threat analysis on our safety goals. So the TARA, the threat analysis, is a shared method which is described in a cybersecurity standard but used in functional safety. Or let us look into something which is used by all of these standards, which is traceability. We need to have a consistent linking between different work products, the requirements, the design, the test cases, etc. This is defined not even here, but in other standards like Automotive SPICE, which is following this ISO 33000 series, which is a standard set about processes and process improvement, which again builds upon the classic ISO 9001, but also the specific application domains for instance, automotive, or the standards for quality management. So we do have overlaps which are minimized because we use references. Now, in the case of automotive, we also have a very specific ultimate standard, which is the so-called type approval. Type approval, or homologation as we call it, means that the vehicle is considered adequate for the market, for the usage, without public risk, without problems. That means during this homologation, certain elements are tested, but the major responsibility is with the manufacturer, the OEM, who has to show that he follows the necessary regulations. So we have here some standards which govern the development, the production, the service, and we have standards which ensure that we have a consistency in the way how this product is developed and later on serviced and maintained, so that it's no risk for the public, that it satisfies all the different regulations which are considered. We will show now how this can be done very efficiently in order to achieve before mentioned product liability, but also to show that we cover the state of the practice without the overhead. I give you a negative example which I often see with customers, which is they would take a book like an ISO 26262 standard, which has a lot of elements, many clauses which have to be fulfilled, and then try to take it as a mandatory set of implementation methods. That's fully wrong. A standard gives us goals which we have to achieve. It gives us alternate methods. It even says in many situations that maybe we don't know yet what is the practice and the best practice in 5 years. So if there is an alternate methods which can be used to achieve a goal which is specified in that standard, that's fine. This is, by the way, the key feature of any standard, that they don't prescribe a technical method, but they always say this is what we want to achieve. For instance, functional safety. This is how we are going to approach it, with an analysis, safety goals, with the necessary design and testing, and of course later on maintenance. Same for security, same for many other functions and qualities of the vehicle and any other technical system. But they will not say, and here you have to use object-oriented development, and here you have to use a specific tool, and here you have to use this set of coverage for your test cases. We just don't know. Of course, these standards talk about the typical verification activities like a unit test, like MCDC coverage, etc. But they are never saying this is the one and only. They say maybe there can be also others which satisfy the same goals. So efficiency in the use of standard means two things. One, you have to see how you can implement the standards without the cut and paste, but rather that really satisfies the goals. Two, that you look at standards in their relationship and not simply say, here we have our safety experts, here we have our security experts, here we have our reliability experts, etc., etc. This would be a huge overhead. I've seen companies where they have this kind of ivory tower of the safety people who come with their safety regulations to be applied. And then there's a next ivory tower which has been recently built, which is the cybersecurity. And then comes the question, so how do they now cooperate? Well, this will not work. Think about an agile development process. And you have all these agile function or feature teams. Do they have all of them safety and security experts in the team? Impossible. You need to make some sort of pragmatic push-pull to avoid that you have here the ivory towers with the experts and the theory, and you have the practitioners who have to cumbersome translate. Best possible solution is try to approach these standards together, derive what is a good method to do it, use your ASPICE and other basics which give you the process layout, and do it. Let's see how this is practically done. One way to merge safety and security is that we have a look to the life cycle. We see without much, let's say, creativity that there's a huge overlap in terms of how to best implement. From the requirements to the design, to the verification, and even to the maintenance and service. We see there can be a lot of interaction between safety and security. In fact, we have to do that because a safety requirement and a safety implementation have to be protected against manipulation. So it's good that we have this overlap. On top of that, you can also see that frameworks like the before mentioned ASPICE or CMMI also overlap. That means we have certain elements in the standard which are, let's say, unique, others which point to each other, like we have a pointer which goes from safety into security, that is the TARA as a shared method, and we have like a traceability, something which is prescribed by ASPICE. This is exactly how we can efficiently use the standards and then orchestrate the use of the standard in a good method. And with this, we can then dig into each single standard, like cybersecurity, where we see that the layout of the standard is very straightforward. It has elements of culture and organization. It has elements of how we best approach the project, and then, of course, also for each of the development lifecycle activity, how we practically do the systems engineering from a security perspective, how we do the design, how we do the testing, how we do the service. And we realize it's a pretty similar structure, even the underlying V, towards an ISO 26262, which allows us to make this orchestrated approach. Let us look into how we can do that in a pragmatic way, also considering the homologation and the type approval. Type approval in a nutshell is governed in most parts of the world by a United Nations organization, which is not ISO, which is another United Nations organization, but the UNECE. UNECE is a group which specifies the type regulation requirements. There are many of those, which are typically regulation like R, and then some numbering which shows which is the regulation. There are regulations, for instance, for headlight. It's the R48. There are regulations for diesel particle size. There are regulations for almost everything, but it's clear because they have to ensure environmental aspects. They have to protect, of course, against theft, functional safety, connectivity, information sharing. That gives you an idea about those regulation topics which are cybersecurity specific. UNECE has created two standards which are relevant for the cybersecurity management and the software update management, CSMS and SAMS. These two, of course, have also their relationship, their overlap, which are governed. That is, the software update management, for instance, says if you use over the air, OTA, you have to make sure that this is a secured transport. They do not describe how to secure it. This is governed in the CSMS. That means how can we use cryptography, how can we use key management, etc. But even here is a fine line, because CSMS would then also refer and use methods which are prescribed, for instance, the 21434. So the ISO standardization of the ISO 21434, which is looking into this relationship, takes, of course, also care that later on there's no contradiction to the type approval. In other words, the whole UNECE framework is also helping us to do cybersecurity together with functional safety, because it's clear a software update has to make sure that we don't violate safety regulations. That means the chain from an initial software change and its impact analysis to the different regulations has to be consistent up to the moment where the update is delivered into the car. And inside the car, also the delivery process has to be in a way that driver is informed about changes which have an impact, for instance, on safety or on any other regulation, and that the driver can then also say that this update would be installed, or maybe it's not completely in the car, then it would not even be triggered, and then there's a fallback. All these mechanisms are specified in the SAMS. From a practical perspective, we look that we have this safety and security process along the life cycle. So this is like a swim lane approach for these different standards, and make certain orchestration or synchronization points. For instance, we make a safety analysis, a HARA, with the hazards. Then we check, of course, how could a related attack or an attack vector impact our hazard analysis. How could it create a new hazard? Or we have a safety goal and we analyze how could this safety goal be manipulated by an attacker. And that helps us to safeguard functional safety in our cybersecurity. And that's of course a very useful start, because at the end of the day we don't have infinite resources. We have to deliver. We have to also make sure that we address the major risks. And that means if you have an ASIL CD function, that's of course a major risk if it fails. And for that reason, we should rather ensure that from a cybersecurity perspective, these ASIL C and ASIL D goals would not be subject to any kind of manipulation. Now, another topic which we also have for standards interface is the secure information exchange. That means a 21434 simply says you have to ensure that the information is securely exchanged. This is also, by the way, a part of CSMS and SAMS of UNECE. But that means also we recommend that you establish as a supplier or OEM always this kind of secure interfaces for your document exchange, independent in which direction, that you make some sort of coordination along the life cycle and the supply chain, but do not try to make one for each of your customers, because this will end nowhere. It would be just too complex. Try to have a generic framework. This is how we typically implement it with our customers, and then you can adjust it for the specific situation. Of course, TISAX and CISAX would be also necessary, because these give specific frameworks in the way how we can, for instance, make a structured information, cybersecurity information exchange, a CyBEX, which help us then to make this document and information like key management, etc. secure. Finally, a guidance in this interface between OEM Tier 1, which is, as an OEM, we need of course a company-wide safety security standard framework, because we have this type approval requirements of the UNECE, but for efficiency purpose, connect as much as possible in order to make sure that your safety goals cannot be compromised. That means also that increasingly we converge our IT and EE organizations, because embedded is not anymore embedded, it's also cloud and back office, and IT is not anymore only IT, but it's in the meantime also real-time and safety critical. That means we have major changes also in the way how we organize our development together with our IT organization. Ask your suppliers to commit to specific standards, to commit to specific needs which there are, without demanding that they talk exactly your language, because that will also on the OEM side create additional complexity. From a supplier perspective, demand context information. Often we have suppliers which say we don't know really about how to do this, what are the underlying frameworks which the OEM is using, and this will not really give us a good value. That means it's better to take assumptions, make workshops. We often orchestrate these workshops together with OEM and supplier in order to identify a useful framework which helps us to set up not only the right safety and security goals, but also consider the interface parameters and therefore make it robust against any kind of change. Finally, establish an OEM supplier development interface agreement, a DIA. We know that typically from the ISO 26262, but we can of course also apply it to cybersecurity and later on to the SAMS, to the software update management, and to the CSMS, to the cybersecurity management. And finally, perform periodically audits, updates, reviews and improvements, so that you can grow, that you can improve, and that you check your assumptions with each other. This being said, we can clearly address product liability, not only from a piecemeal approach, but also from an orchestrated approach of the customer and the supply chain. This being said, you have now an overview into how to efficiently orchestrate different standards with respect to safety and cybersecurity, and UNECE, SAMS and CSMS. These standards overlap, but they will be always aligned with each other, so you have shared methods. And if you organize your development, both embedded and IT, accordingly, it's not really an overhead. If you need more information on that, if you have specific questions, if we can help you with setting up your 21434 or your UNECE, just contact us with www.vector.com/consulting. Wish you good success in implementing these standards and make sure that you do always your impact analysis so that even a software update management in an increasingly fluid way over the air would not suddenly result in certain mismatches between initial type approval and later software updates. Thank you very much and good success.